All right, let's start talking about the engine and parts of the engine. We're going to concentrate this week on the bottom half. Bottom half is everything that doesn't include the cylinders. Cylinders are the top half, and the rest of it is the bottom half, or the bottom end, if you will. So let's start talking about the crankcase. Now, the funny thing about the crankcase is whenever you read anything about a crankcase, and I just stole these pictures off the internet, is that they say the crankcase is like, and I'm going to see who did their reading. Like a dolphin? No, it's not a dolphin. A what? Dolphin. Crank. So nobody did the reading. A crankcase is like, well, it's like your backbone, is what they say. Which makes no sense to me, because if I went to the doctor and said, Doc, I got this problem, my back really hurts, and they says, well, it's your spine. What's a spine? It's like a crankcase, Kevin. No, I don't think so. But they say it's like your backbone, I guess, in the way that. What's that? That's what I say. It's more like a rib cage, but their point is that it has a lot of functions. Number one, it's got to, I guess your spine does too. It's got to kind of hold you upright, and it's this main support. This is the main support, because look, these holes right back here, I mean, that's where it goes to the motor mount, right? So this has to go onto the motor mount, and then, something you may not have thought about, but what goes on the end of this flange right here? Propeller. So the propeller is pulling the airplane. So all of the pull of this is pulling the crankshaft forward, which then rides right back in here on this thrust face, which, did you notice, is not even a bearing?
That's interesting.
It's a steel on aluminum.
Wow. That's really interesting.
Yeah, Continental uses a bearing there, but Lightcoming does not. It's something else to think about. So, there's that. And that's assuming this is a tractor type application. A tractor type means that the prop is in front of you like a regular airplane, and it pulls you through the air. If this was a pusher, in other words, the engine's in the back pushing you, then the thrust face is these little tiny slinger rings up here. So it doesn't, but yet you don't hear failures. So crankcase is like a backbone, right? That's what they say. I didn't even write that. I'm not writing it. Maybe I will. Crankcase. Well, it is the case of the engine. Case of the engine. I think that was my way of not using backbone. But it has a lot of functions, if you really think about it, which you're going to have to now. Well, it must support itself, unlike a lot of you.
What's for B? Is that functions?
Yes.
Oh, it looks like a D.
I don't care what it looks like. It's functions.
It looked like a D. I put a DU, and then I go, wait a minute.
Okay, so we do have a rule. Did you hear the rule? Would you like me to explain the rule?
By all means.
The rule is I don't have to do all this writing. And as far as I know, I'm the only instructor who does it. So as soon as you start making fun of me, I put the pen down and I just start talking, because it's a lot more fun for me to do it that way.
I didn't know that.
Yeah, so there have been many nights where I've actually done that. I'm like, well, I'm done writing for the night.
Like, I didn't know. Right?
The other thing is you can try writing on this. So, all right, it contains the bearings in which the crankshaft rotate. Contains the bearings in which the crankshaft rotate. You notice the camshaft does not have bearings. It's also just in aluminum. You know what's funny? Never seen one wore out. Never. It must provide tight enclosure for lubricating oil. You don't want that oil splashing all over the place. Hot oil makes a fire. Fire is bad. Support various internal and external components of the power plant. So support various internal and external External components. What kind of components do we have? Can't think of any internal offhand. I mean, it's internal. It's pretty much the engine. Everything is external. But not my words. What do we got? What components we got hanging off this thing?
Oil pump.
What's that? Oh, what's that?
Oil pump.
There's an internal oil pump. Kind of. 0470 is a little more external. Yours is a little more internal. What else we got? Oil pumps, alternator, magnetos, starters. There's a tach drive to run the tachometer. Sure. We've got, what do we leave off with? Prop governors, carburetor, fuel injection, vacuum pump, hydraulic pumps. I mean, it's got to do it all. Provides mounting for the airframe. Provides mounting attachment to airframe. And provides support and attachment for cylinders. Oh yeah, air conditioning system?
We're saying air conditioning could be an
Yes,
internal thing.
it could be, yep.
Big controversy over here about that.
All right, it's got a lot of things it's got to do. What's it made out of? Aluminum casting. And that can come in two different ways. There's something called a sand cast. It's much rougher. Much rougher. And I'll write this one. So if you can't do something right, best make an excuse about it, right? So if you do a sand cast, which I don't know, I wasn't there. It just seems to me like probably that was just the way they did it back in the day. So they started, because they got the sand and they poured the mold in and made it. And that's the sand cast, and it came out rough because of the sand. And so as years progressed, now they have investment casting, which is much, much smoother and nicer. And if you watch videos and stuff on how the difference, investment cast uses a whole wax process. It's pretty cool. And sand cast is not. But so at Lightcoming school it's fun, because they talk about stuff like this. Like, well, it's supposed to be rougher. You look at the surface, smooth surface, versus one that looks like this under a microscope. Well, every one of those little peaks and valleys, every one of those peaks, that's a cooling area right there. It's more surface area, so it dissipates heat much, much better. Sure it does. So.
But which one looks better?
I'm gonna write it, so. Question mark. And then there's the permold. So you have sandcast and permold. And as far as I know, the only one doing permold is Continental. And that's the one with the integral alternator drive. Where I had the picture. Let me see. There. Is that a permold or sandcast? Permold. Why? Because it's got the alternator. That's all. But we know that they also call it investment cast. I could have wrote that. Investment cast. Just another term for it. All right. See, it's definitely aluminum. And it comes in multiple sections. Oh, I was just going to say this, but it's in my notes. Good for me. Okay, the opposed engines. Well, obviously, you've got an opposed engine. How many sections do you have to your crankcase? 2 sections. One could argue possibly 3, but I'm just going to say 2 because that is the crankcase is in 2 sections. That third part is an accessory case. That's different. They are non-interchangeable. In other words, you can't take your left hand and trade your left hand with them. They are matched and machined together. So they're non-interchangeable. Match set. Very matched set. That's the opposed. The radial engine is a little bit different. The radial. It has 3 to 7 sections. Oh, where's my radial picture? Radial. There we go. There's a radial. Stole this from Gary Brossett in 2003. Thank you, Gary. So we've got the nose section. You got the power section. You have the diffuser blower section. You got the accessory section. This is 1, 2, 3, 4. This is 5 sections right here. Your nose section contains the thrust bearing up here. So you always got to have a thrust surface. Remember that. So you know where yours is. It's back behind the shaft. Well, this one's going to have up here a big old ball bearing up in here. That ball bearing is the one that takes the thrust and transfers it to the nose, which is the thrust case. And by the way, this would also then have the cam ring in it because these are the lifters right here. The power section is in 2. I can see the split right there. So that means that it's got fore and aft. Sometimes the power section is just one piece. Then the way these pipes come out, that's going to probably be the diffuser, intake, or blower section. And then I just know after that's going to come accessory sections, which could be a few of those. So there's quite a few sections to them. Thing about radials, I tell you, it's a little monotonous building radials because you do the same thing over and over and over. I don't know, you'd think that it's like, well, you know, you're building even a 7-cylinder radial versus like a 6-cylinder opposed. You think, well, what's the difference? It's one more cylinder, but it's not. It's just something about it is very tedious and repetitive on radials. So you have the front, or often nose section, and usually contains the thrust bearing. Bearing. You have the main or power section. And I pointed out that it's 1 or 2 piece construction, and there's a point to that. If it's a 2-piece crankcase power section, in other words, you can split the crankcase, so you have a half circle and a half circle. That means that you have your crankshaft is usually one piece, and you build up the crankshaft, and then you take these and put it together. If the power section is not a 2-piece, that means that the crankshaft must be a 2-piece in order to become a part and be put inside there. So you have a multiple piece crankshaft. I'll show you that. 3 would be blower or diffuser section. Blower or diffuser section. And then we'd have the accessory case after that. Can I move over? Sorry, I wasn't talking to you. They're Siri or whatever the hell you were. Good? Yeesh. Oh my gosh. Bring my couch in here and sit down. You guys think so long. Moving over. All right, point E. So opposed engines. Use through bolts. You've already been exposed to these through bolts. I'll say there are two types. There are the fixed and the floating. And got my pictures. Here, go back. Yep, backwards. All right. Is that fixed or floating? Probably fixed. What goes here? Could be fixed in the other case. I don't know. It's a trick question. But let's take a look at this one. This one has fixed and then floating. And that's more common of like the 320s than the 360s. A lot I could say about this particular picture. So you obviously have anchored on one side. And with floating, there's a couple of things. And one, that's where it becomes so critical to torque both sides of them. And I think I told you when I built engines, my buddy Nathan, who I worked with, I'd always call him in, and we just, it was like a little dance, man. We could do it. So I love working with that guy because we just get in a sync. It's next. We know which one, and click, and we both click about the same time. And we go through the whole sequence and make sure everything was torqued simultaneously. Not me doing this side, then walk around this side. We literally calibrated torque wrenches, both sides at the same time, and checked them all. The other thing is, I'm looking at this picture. Can you see the little O-rings down there? Now, O-rings, you need to be careful. When you slide an O-ring over a stud like that, when you slide over the thread, you damage it. And how do you change out a damaged O-ring in this location? You don't. You take apart the whole engine. That's very expensive. So you don't want that. And then if you get a damaged O-ring, well, then the oil starts seeping through here and starts leaking out of the out of the through stud. And Michael, what do people do then?
Didn't they use like RTV sealant?
Sure, they shove some RTV. They take off one of the nuts and shove RTV sealant on there, and then they put the nut back on. In the training that I just had, the NTSB, they showed people who died because somebody did that. They shoved some RTV in there. That RTV did work its way through here. It's hard to believe. Went right in through that little hole. What is that little hole? That's the oil passage where the oil pump feeds oil down through the oil gallery, down into there, out through here, over into here. So it started it full of oil. Crankcase seized up, broke, killed people. Right? It all started with bad O-ring. So when you put O-rings on, I had little O-ring installers, which were just little caps that I had made out of phenolic that would just barely slide over and had a little point, like a little cone. And so the O-ring would just go over the cone, slide down the little slippery thing until it got to about this point and then rotate down. But, if you don't have those, it's no big deal. I just take the package that the O-ring comes in or a piece of binder paper, just rip it, wrap the binder paper around, put a little twist on the top, and just slide it across the paper. It's just, no big deal.
Yeah, the electrical tape can use that too.
Anything you want, yeah, that protects the O-ring going down. Just take time and care.
I think that's a Q&A question too.
Is it?
Mm-hmm.
What's the question?
It's how do you not damage the O-rings, and they say to put paper over it.
Oh, so I'm right. This one is hard for me to explain just looking at this. You guys have bearings that go in the halves, which is quite nice. That's not normal for Lightcoming. See, you have a 1 and a 2. This is one piece, goes all the way down. Not only that, the split is right down the center, right where the little hand, can you see the hand going back and forth? That's where the split is. And so in order to put that in, you actually put the bearing on the crankshaft, and then you bring I bring the case up too, and there's dowels that it has to fit in. And that's what these marks are representing. So there's a mark going here that shows, so you're supposed to put it together like this, and then mark it, without the crankshaft. Put the bearing in without the crankshaft, then you mark it so you can kind of get some reference lines and put it together. I'll try and find something to show you how that works, because it's very important. And if you slip, the little dowels going, they miss the holes and they just push right into the crank. Oh, you know what? The crankcase with the fretting,
Yeah.
they did that. They smashed the bearing into, so you get to see all that. You have to remind me to do that. So, okay, we got the sealant. Okay, so let's look back at this again. So we've got to seal these crankcases, right? And so this is where, you think the O-rings are bad. This is where the rest of the bad problems come. So this is no gasket. Can't have a gasket because this is metal on metal. It's a critical tolerance for how much opening you have for these main bearings. So metal on metal, we don't want fretting. You know what fretting is now. If you have fretting, that means you're missing material here. If you're missing material here, you can overclamp this bearing. Overclamp the bearing, you don't have enough crank to bearing clearance, you seize up an engine. Kill people, right? Okay, so there's this whole thing about how do you seal this? Well, mechanics are an ingenious group of people. And so sometimes they'll RTV must work great, or all kinds of sealants. Lightcoming and Continental both are very, very specific about what kind of sealant they want. Now they do give you some choices sometimes. This is kind of I want to say it's the newest method, but I was doing this 20 years ago because it was allowed back then. But this is a Loctite 515. It was under a different name. I think Continental started using it, and they had it only under a Continental part number, but then they said, okay, it's Loctite 515. It's made by Loctite, but it's not a Loctite like you're thinking, like it's a thread locker. It's an anaerobic sealer, so when it's devoid of air, it's going to seal. And so look how you can actually see the base metal through it. This has been applied correctly. You should see the base metal through it. It's just a super, super light film.
Is that prior to being torqued down, or is that after, once it's been split and it's just been on there prior to
They're building it. This is getting ready to be put together.
That's how it's applied?
Yes.
Oh my God.
Yeah. Now, Continental, they're weird. And it was funny. I was talking to Larry about it, and I was like, yeah, this is how you do it. And it's such a weird thing that I even started to question my own sanity that I'm telling him the truth. He's like, are you certain about that, Kevin? Because that sounds really weird. I'm like, yeah, no. But that's how I did it in the field. I had to go back and read it. I'm like, yeah, I was right. They use this 515 on one side and a Pliobond on the other side. Two completely different manufacturers, two completely different chemicals, and bring it together. It's bizarro. Yeah. Oh, I actually wrote it on here, so I guess I'm right. So let me see. So sealant. But again, this is probably the number one area where people mess up. Sealant. I even got into it with somebody who used to work around here, who's not here anymore. It's like, it's all the same stuff. I'm like, no, it really isn't. So let's talk about Lightcoming. Lightcoming. Lightcoming wants you to use double-aught silk thread and POB number 4, Pliobond number 4. That's what we're going to use here. Now, according to the Lightcoming guy, and I don't even want to write this. I wrote it down to remind myself that he said this. He said the silk thread will eventually wear away, leaving only the Pliobond. Now, if the silk thread wears away, that means that the cases are fretting. And they shouldn't be fretting. So don't say that. So I'm not going to write it. I want to say, and then Lightcoming also has, you can also use the, what do they call it, Loctite 515. But you don't use silk thread with that. I like the silk thread. I always wanted the silk thread because I don't know, there's just something about having the little threads there that made the sealant. I liked looking at it. I don't know, so I always use the silk thread. Continental uses 654663, which I think is on 1/2. I'm just going to make it simple, on 1/2. And then I wrote this is Permatex. It's a Permatex product. Permatex form a gasket. Form a gasket. You can't really use this if you're doing an engine. You can't go, well, that's what Kevin's notes. And then 646942, gasket maker on other side, and it's very specific. This is the like 1324. Gasket maker on other side. To be technical, it's the 13 side, or 15. Not to exceed 0.010 inches thick. So you can see they get pretty specific about it. And then, oh, that's the Loctite 515. So you put your Permatex form a gasket on one half, your Loctite on the other side, and then some 64153 silk thread. Oops, silk thread on the 246 side. A continuous single piece of grade D silk thread. Now notice that in the Lightcoming, what kind of silk thread I use? Double aught. And Continental says 641543. So what does that tell you?
Different item numbers
Okay, where are you going to get your silk thread for your Lightcoming?
from like
Anywhere.
I got from Amazon. Because why? Because they said double aught silk thread. So as long as I'm getting double aught silk thread, that's what they told me to use. Where am I going to get my silk thread for my Continental?
From Continental.
Damn right I'm going to get it from a Continental supplier because it's called by part number 641543. It does not say or equivalent. It says 641543. So I'm going to use 641543 silk thread, which by the way is about twice as thick as the Continental stuff, or the Lightcoming. It is much thicker. Yeah.
So even though you have the part number, you still have to go to Lightcoming or to Continental?
You don't have to go to
can't
Continental.
anywhere else if they have the same matching part number?
You can go anywhere you want to buy it.
Just as long as it has the matching.
Has a part number on there. Like, you don't really go to go to Aircraft Spruce. You know, they'll have it. So, what if they do? Let's see, that was 641543. What?
That says dash 4 down there.
Hey, silk tie.
Did you need? Oh, yeah.
Don't see it. Let's try this. Part number could have changed. Don't see it. Probably the same thing. Just take it apart. Fresno Air Parts. So beware where you get parts. That's my point. Oops. Okay, so there's different ways. So make sure. So how you going to do this though? I mean, really, I've told you got to do this. Now you know there's something about it. How are you going to handle that? That's the obvious answer. Interestingly enough, of course, Continental, or sorry, not Continental, Lightcoming, as they do, it's written one way in their overhaul manual, another way in the service instruction. So I always go with the service instruction because they're updated more frequently when have the latest information always. All right, so there we go. That's how to seal them. If a little bit of sealant is good, then a lot is worse. What happens if you put too much sealant in there? Then it's going to hold the cases apart. Then what happens?
Whatever the right clearance.
Then the sealant wears out, and then the case starts fretting, and then everything goes to hell in the handbasket. And so, yeah, so use the appropriate amount. And by the way, this Permatex stuff, oh man, it just gets on your fingers and it doesn't come off. You definitely, my shirt's stained with.
Is it kind of like Bona?
Who? Bona?
Bona, like so for us, we use Bona for the tanks, to seal the tanks.
Okay, not use that. It's a one part, so it's not two part, and it's, well, you're gonna get to use some because I think that's kind of, it's very much like the Pliobond.
Isn't that the same as the car Permatex?
Yeah. Well, Permatex is a brand name, like Loctite's a brand name.
Yeah.
All right, let's talk about bearings. Lots to know about bearings. What is a bearing? Any surface that supports another. So just because it doesn't look like a bearing or you can't take it out and hold it doesn't mean it's not a bearing. Like for example, how about your camshaft bearings? We don't say camshaft bearings because that implies that there's something you could take out, but it's definitely that camshaft boss is the appropriate term, is a bearing surface. You had your rocker shaft, went into the rock in the head. Well, there was some bronze oil-like bushings in there. Okay, those are bushings, which are a bearing surface. Your piston pin went through not only the piston, which had a piston pin boss, which is a bearing, but also went through the connecting rod, which had a bronze or brass bushing in there, which is a bearing surface. And of course, you had the bearings, the main bearings and the connecting rod bearings that you took out. So we have all different kinds, but we're going to mostly talk about ones that you can replace. Functions. Functions. Well, it's kind of hard to make a bearing. So material must be strong enough to withstand pressure. To withstand the pressures. Let me see. I should have wrote without deforming. Kind of like being a teacher. Permit turning of the part with minimal wear and friction. Held to close tolerance. In other words, they have to be the same. You can't have one bearing that's, that one's, a couple, 3,000, 4,000 thicker than the other half. I mean, they've all got to, when they come off the plant, they got to be the same. And when you buy bearings like for your engine, believe it or not, it's just, you need 8 of the main bearings. It's not like a right and a left. It's just 8. They're the same. So you have 8, and then you have 8 for the connecting rods. So it's 8 of one style, 8 of another. Yeah.
So if you had to replace a bearing, would you replace all the bearings at once or just that one bearing?
It depends on why I was doing it. Like if I ordered 8 bearings, and this happened all the time, I would go to build the engine, I'd pull one out of the box, and it's got a big scratch on it. I just get 1 to go with the other new 7. But if I took the engine apart, then I wouldn't reuse the bearings anyway. It's like, they're not that expensive, compared to what you're doing. They're shockingly expensive compared to car stuff, but held to close tolerance, obviously provide, this seems redundant now, provide freedom of movement. And withstand high loads. There are different types of bearings. Got your plain bearings, which go in planes, right? But it's spelled different. Plain. All right, where do we find plain bearings? They provide radial and thrust loads. So what's a radial load? Give me an example with your engine.
Wouldn't that be the journals?
Which ones?
The crankcase, the ones that are inline with the,
The main bearings?
yes.
There you go, main bearings. It's going round in circles. That's a radial load. Okay, how about the connecting rods? Radial load. Where's the thrust load?
Thrust bearing.
The thrust bearing. Where's the thrust bearing? You don't have one in that engine. I mean, you do, it's just not replaceable, right? So it's where the crankshaft butts up against the crankcase, right, in front of the number one throw, and that's the thrust right there. That's the thrust load. But technically, I guess it'd be a plain bearing. It's just not replaceable. So we got plain bearings. They provide thrust and radial loads. Materials. In a nutshell, it's a steel shell with some material on it, like a copper and then a babbitt goes over it, which is a tin-colored stuff. But they've been known to be made out of silver. You hear me talk about the Continental. Actually, it's kind of an interesting story, I think, if you're into a little bit of history. You know, the V-tail Bonanza, I think, is a tremendously cool plane. And so what happened, you know, World War II is ending, and Beechcraft, their main aircraft is the Stagger Wing Beech, which is a double wing, tube and fabric, massive amounts of labor to put these things together. So Beech decides that he's going to mass produce an aircraft that he can sell to all these GIs coming home from the war, right? And believe it or not, at that time, they didn't have any six-cylinder engines that would fit this. They had radial engines, which is what the Stagger Wing used, the Pratt & Whitney 985, 450 horsepower. So they needed an engine that would actually work with these V-tails. So Beech went to both Lightcoming and Continental and said, hey, we want an engine that's 185 horsepower that's going to, you know, work in this airframe. Give us what you got. So Continental produced what was known as the E185, which is basically 470 cubic inch parallel valve engine. Lightcoming produced a four-cylinder engine that had a gear reduction in it that spun the engine much faster through a gear reduction, so the prop turned at the same speed, and that's how they got the horsepower to 4 cylinders. So Beechcraft tested both engines and selected the Lightcoming. And Lightcoming said, okay, we'll do this. Here's our production time where we're going to give you the first engine. They did not like that. Went back to Continental and said, this is when we can give you our first engine, which was much, much sooner. That's how the Continental won over that one, which I think was, I don't know if the V-tail would have made it with a geared engine or not. Cessna tried the geared engine with the 175. It's a 172 with the geared engine. Never really, not a popular engine. So anyway, that's how that happened. The thing I hate about the E185s, which is why I'm telling you that story, is they use silver bearings, which are nearly impossible to find. I mean, I overhauled one many, many years ago, and it was like when I finally found a set of bearings, the guy who sold it goes, you know, this is my last set. And which sucked because then the pilot crashed that airplane. So they use lead or an alloy, which could be bronze. And there's a trade-off with everything. So bronze is good under pressure. Good under pressure, but has high friction. So it's going to wear out sooner. We have babbitt, which is like a rabbit. B-A-B-B-I-T-T, which is, what is that? Well, it's tin. Like, okay, I got that. Copper, Keep talking. I understand. And antimony. Okay, you lost me again. Well, that's what you pay your ex-wife, I think. I don't know. The guy who made it, he's like, I don't know, and I just write a check to my wife, so there's antimony in it. Okay, that's the opposite. So it has low friction, but not good under pressure. But not good under pressure.
What do you mean by that? Pressure.
It'll deform. So like you get a lot of pressure against it, it's going to deform and wear out. There was the silver. Silver, good under pressure, good heat conductor. Friction qualities are not that dependable. I'm not going to make you remember all that. Let me see. All right, good pressure, good under pressure. Friction is not dependable. Not dependable. And this is the common alloy. What we got now. So like I said, we have a steel backed with silver, not likely. But the thing that I stole this from said silver or bronze with lead sprayed, with lead on top. Or, I think this is more common, a bronze or steel backed with bronze. Steel backed. This is steel backed with lead or Babbitt. I think most of it is a steel backed. You're not going to use silver, but you use bronze. So steel backed with bronze and lead or a Babbitt surface on top. So what you get is that dull gray finish on top. And if you scratch through that, you're going to see it turn gold. And you scratch through that, you're going to see it go back to silver. So that's why when you're looking at an oil analysis, and not everybody does it, but a lot of aircraft owners, we take an oil a sample every time we change the oil in our aircraft, and we send it out for spectral analysis. And we look at what is in our oil. And we're looking for bad things that could be happening. So if we see we're starting to get a lot of bronze, like maybe you're always going to get a lot of lead, so that one's really hard. But if you get tin, and then the tin starts to go away, then you start to get more bronze, you're eating through your bearings. So I'll show you my oil samples when we get to that point. Yeah, we got enough time to do these two. So there are different types of bearings, plain bearings. So not only do you have the different materials, but you also have different types. There's the tang type, tang, and so it has the tang. It has the tang to hold in place. Hold in place. Or you may have a dowel. Dowel. It uses a dowel to hold in place. The dowel is in the case, and so there's a hole in the bearing. Dowel to hold in place. And there's also a thing called high crush, which has a tang, but sticks up about 0.003 of an inch, or 0.003 inches higher than the surface, higher than the parting flange, and is crushed into place. I don't know if I've ever done high crush bearings. Definitely Tang and Dowel are very common. They're the most common. So that's plain bearing. The other version would be called an anti-friction type. And that is where we will start tomorrow.